Hello and welcome to this CGI Studio tutorial on data binding. We will start from an already existing scene in which we have a few controls. The values associated with these controls can be data bound. On one hand, this allows an application to set values controlling the display. But the application can also receive requests to change values in case of user interaction. For this text value control, we can see that most properties are bindable. There is a specific icon to the right of bindable properties. They are colored white if no binding is set. If a binding is assigned, they will be colored blue. Data bindings are usually defined in an XHCDL file. The definitions here could specify various basic types for each item. They could also use custom types like color, and they could be grouped or structured and named according to their intended use. For the Community Edition, we only have the predefined data binding. This provides us with 10 binding source groups, each containing 10 items. Each item is a variant, meaning it can handle several types: string, bool, integer types, and floating point types. To set a data binding file for our solution, click File. Then go to Define Application Specification. Then browse to the XHCDL file. Now we can bind our values using the defined items. We will start with the right side on which we have no interactive items. This is a regular text control. The text can be set and is bindable. Other properties may or may not be bindable. Click the binding icon to select an item to bind. Let's use items from Binding Source 5 for the elements from the left. Just select and click OK. The value is now bound to Binding Source 5, Item 1. This node has behaviors attached to control its position. There are separate values and setters for X and Y. You can see how it moves on the X-axis when we edit the value. So let's bind this value. Let's set Binding Source 5 Item 2. The Y-axis setup is the same. Let's bind with Binding Source 5 Item 3. Here we have a text value control configured with a decimal format. It will simply display its value property. Let's bind with Binding Source 5 Item 4. Next, we have a setup with two text nodes. A render child node's behavior selects which is visible. A map value behavior maps 0, 1 to 1, 2. So value 1 should show the true text, and value 0 will show the false text. The bool value can be interpreted numerically. Let's bind this value with Binding Source 5 Item 5. Here we have an image node with an attached set alpha value behavior. The value is a float between 0 and 1. 0 will make it most transparent. 1 will make it completely opaque. Let's bind this with Binding Source 5 Item 6. In the last group, we have a text value control again. This time the format is set to floating point with 8 decimal places. Let's bind this with binding source 5, item 7. We can also use the predefined data binding in the player. From the Controls tab, we can set control values. Here we can see all the properties of the controls. We also have a data binding tab which is initially empty. You can press the Load XHCDL and browse to our file. Here you can see all the predefined binding sources and items. You can select data type for each item, and you can edit them and notice the value change in the player. Item 1 is the string. Item 2 is the X position of the image. Let's just move the windows for a better view. Item 3 controls Y position. Item 4 is for the int32 value. Item 5 is for the bool value. Zero for false, 1 for true. Item 6 is the alpha value. Item 7 is the value for the displayed float. Now let's take a look at the left side. The elements here allow user input. For the input field control, there is a small workaround. It has a value behavior attached to a forward value behavior. The value is forwarded to an invisible text value control. We can make it visible temporarily, and we can see the value forwarding in the player. So the text value being typed is forwarded. We can use a data binding with this item and catch text change requests in our code. Let's bind with binding source 1, item 1. To set a vector X position, we have a slider. The user can drag the slider to change its value. At design time, we can set it here. Let's bind it with binding source 1, item 2. For the Y value, we have the same setup. Let's bind the value with binding source 1, item 3. The int32 slider is configured for a very big range, so we have to type a few digits to see it move. Let's bind this with binding source 1, item 4. Next, we have a toggle button. Let's bind this with binding source 1 item 5. The alpha slider is a float from 0 to 1. Let's bind it with binding source 1 item 6. The float slider has the same setup. Let's bind it with binding source 1 item 7. We now have a binding for each element. Our application can set values to all the bindings. And when a user interacts with a control, it can receive the value set by the user. Let's take a look at a basic Python script. We need to use the Candera app connector and generated binding source enum. We take the library path and asset binary path as arguments. Here we get a logger, which we can also see in the console. We then use the provided arguments to load the asset and set up function calls. We can register one of our Python functions as listeners to value change requests. When a user drags a slider, for example, a value change request will be caught. And we can call step in a loop. Let's run the script. We can see a console window in our app. For a quick test, we could slightly increase a float value in each step of our loop. And we can call setFloatValue to set this value to binding source 5 item 7. And we can use setIntValue on binding source 5 item 4. But this will only be called once every 2 seconds. Let's see how this looks. So you can see the float constantly updating, and the int occasionally jumping. Now we've seen how we can set values to bindings. So let's comment out this quick test. Now let's take a look at the binding callback. This function will be called with the binding element and the value requested for it. Depending on the value type, we have to call a getter on the binding. We can log this value to see it in the console. We then set it to the binding for which the change was requested. And finally, we can also set it to a corresponding element on the right side. There are getters and setters for string, float, int, and bool. With this setup, user changes to the elements on the left should also affect the elements on the right. This could have been achieved simply by forwarding values in the solution. But this shows how values can be received and set based on application logic. Let's see the behavior in the player. Typing text here modifies the string on the right also. And we can see the values received in the log. Dragging this slider modifies the X position of the image. And very large int numbers can be set. The toggle state is shown as true or false. Transparency change can also be noticed. We can also place a breakpoint to confirm a user value change is received. This is hit as soon as we move the X slider. We don't always have to set a binding to the value requested by the user. For example, for the int32 value, we could set a maximum limit. So if the user sets a value over 1 billion, we cap it to 1 billion. Let's see this in the player. We can try to drag it over 1 billion, but as soon as we let go of the slider, it moves back to 1 billion. We can now delete this test code. And take a final look to confirm everything works as expected. Everything seems okay. This brings us to the end of this data binding tutorial. Thanks for watching.